Now I know you can see on your angle a little bit of white of the solder resist or solder mask of the circuit board, but when you look from directly above, you can see that it is actually aligned. It's just because of the angle that you are on. So I've got a little spatula here and just the right amount of solder. I can apply that to these, making sure that there's no voids or anything like that. That seems to go in very easily. As you can see, a little goes a long way. But you have to be careful. It's easy, as I did just then. You can drag the solder back out. Now, one of the videos that I watched about doing this process mentioned that there is a limited sort of working time of perhaps a few hours. So it's not something you'd want to put a whole load of, or get a whole load of boards pasted and then shut up shop and go in for the night, come back to it the next day. I don't know exactly what would happen, but it seems that there's some solvents perhaps in the flux that may well evaporate and then spoil your day when you come to actually soldering it and reflowing it all. I'm just going over these, just making sure each one of them has got their fill of solder. Also, it's recommended that you keep the solder paste in the fridge, or at least somewhere quite cold, whenever you're not using it, as it will last a lot longer that way. But I'm okay, I've got a very cold workshop that it can stay in. So now it will be the moment of truth of lifting up this stencil. I've got it clamped down at the moment, and also the camera's very close, so I'm going to reposition the camera and then we'll lift this off, and hopefully it'll be okay and we can get on to putting the components on the board. Okay, that's the camera moved slightly out the road, so let's just clear the decks. Let's take the clamps, just simple spring clamps, off, and move my battery pack as well. And then we'll attempt to lift this vertically, and hopefully we have got our circuit board with the paste on it. I'll bring you in and you can have a bit of a closer look at this. You can see there's no shiny tinned pads visible now, they're all covered up. By this thin layer. So I'm going to get the components out for this, and then we can start popping them in place. We've got one down there, looks a little bit of a mess, this bottom corner one. But I'm led to believe that once you reflow it, everything comes rosy. We shall see. One moment, and I'll get the camera moved again. I've got another board here, obviously not pasted up, because I just wanted to show you on these boards that I've had done. As you can probably see, for the diodes, there's one big pad and one small pad. The small pad is the anode, big pad is the cathode. And then on the actual LEDs themselves, if I can get a hold of this one, let's see if we can zoom in a bit on this. You may be able to make out there, one pad is small, one pad is large. Again, the small pad is the anode, or the positive, and the big pad is the cathode, or towards the negative. And on these boards that I had made up, the big pad along the bottom, the big pad is connected to the negative or the ground. So we've just got to put the big pad towards the bottom. There is a tiny notch on these, but it is so small from above it's really hard to see. So instead I shall just see what each one looks like underneath. And as long as you keep the big pad towards the bottom of the circuit board, then you will be just fine. Unless of course you're using somebody else's circuit board and their design or a different LED, and they may using a different one. So always check beforehand, and if in doubt, just make sure all of them go the right way, and then when you test the board, if it doesn't work, at least all of them are wrong, and so you can just reverse your polarity of your power leads. Excellent. So it's just the resistors now. There we go. So I don't have to worry too much about getting these exactly all in line when we reflow it. Hopefully they will self-align and draw themselves onto the pads. So that will be the next step. So let me just get my soldering hot air assembly thing, you know, the thing that blows hot air. Let me get that. Just before I start, I just wanted to show you my very expensive hot air blowing machine. It was a bargain, I don't know, 30 quid off eBay. It does the job. I've got it set to about 4.5 on the wind speed and about 268. I don't know if that's going to be hot enough. We shall see. I don't want to cook these LEDs unnecessarily, so we shall see. I may need to adjust that. Bring it down. As you can see, I've put the PCB on a tile, a bit of a ceramic tile, just to make sure that I don't burn the top of my worktop. Just increasing the temperature a little bit. There is a bit of thermal mass in these circuit boards. There we go. I'll wait until it goes. You can see the silvering of the solder as it melts, and I just hold it for a couple of seconds afterwards. Taking slightly less time on each one now as the circuit board gets warmed up a bit. You can actually tell whenever it's doing it because you can see the LED or the component just rotating and self-aligning. Bring in a bit closer, you can hopefully see it. You see that? Just moves on. So there we go. This is just cooling down now. Brought you in for a bit of a closer look. Sorry if this is a bit swamped out. Turn the light down a little bit so we're not quite so blindingly white. But as you can see, when you reflow these, it drags them into alignment on the pads. And that's actually a pretty good indicator that the solder is melted, everything is hot enough. So you can see in places, like we've got here, there's just a couple of little solder balls. And sometimes they're loose. I found some that are loose. Those look as though that they're actually managed to be stuck there. Of course, if it was some sort of critical application, then you would be wanting to make sure that those were not there. That's because the reason for these is whenever I got the stencil made from the same manufacturer as the PCBs, they actually emailed me to ask, or with a query, because the stencil openings for these LEDs were smaller than the actual solder pads on the PCB. So I said, well, just make them the same size, in my ignorance. But in actual fact, actually, afterwards, I read the data sheet, as you always should read the instructions last, and the data sheet calls for a slightly smaller stencil cutout. But it's not made any real problems. I think it's just resulted in slightly more solder than these actually need. And so we've got these little solder balls that are left. But this board is not so heavily packed that that's going to make any sort of problem, even if they got loose and rolled about. I don't think there's any way they could make a short. But of course, in other projects, it would be much more critical. That's probably going to do it for this particular episode. I'm actually going to save the actual testing to see if this works. I fancy a bit of jeopardy, so I'm going to save that for the next episode. And we'll figure out what we're going to do after that as well. I may make up a few more of these boards and solder them up. But thank you all for watching. We hope we've been able to learn something. I've certainly learned something. Thank you for watching, and we'll see you on the next one.